Hello friends, in this video we will be talking about the chain rule for differentiation 1. This is the most important rule for learning how to differentiate functions. So I really emphasize that you understand chain rule very well. It is very useful to learn how to use it quickly, because as you will see, chain rule, you can apply chain rule in a long way and in a short way. So and for chain rule I have another video in which I'll go over more difficult problems, but first I'll just explain what the chain rule is, and then I'll give some examples. So I'll first formally derive the answer and then I'll quickly write it, so please follow how to apply chain rule quickly also, but this is very important for you to learn how to use chain rule effectively. Okay, so what is chain rule? So in the previous video we have already discussed things like sum rule, product rule. So let us talk about chain rule. So chain rule says that if you have a function d of fx and if you differentiate it with respect to d of hx, what do I mean by d of fx by d of hx? I will talk in a moment. Till now we have already discussed d of fx by d of x, but still I will talk about this. But chain rule says that if you have something like this into d of hx by d of gx into d of gx by d of x, or you can have, currently I am writing 3 terms, you can have more terms, but if there are 3 terms, and then you can cancel this out and you can write this is equal to d of fx by d of x. Okay, so I'll explain how we can use this, but I hope you are able to understand here. So what do I mean by d of f by d of hx is that if I can write function f in terms of another function h, so then I will get a derivative. I can differentiate f with respect to h. So I will do that in a moment, but basically the idea is that if you first differentiate f with respect to h, then h with respect to g, then g with respect to x, then effectively you are just differentiating f with respect to x. Okay, let us look at a formal example and then we will be able to understand what we mean by that. So let us take example number 1, and example number 1 is d by dx. Question asks us to find d by dx of 1 plus 3x raised to the power of 4. Okay, so till now we have only seen functions like x cube, sin x, cos x, or square root of x, but this is something inside a square root which has some power, so we haven't seen how to differentiate these things. You can do it very quickly, but first let me explain a long way to do it. So we know how to differentiate a square root function. Okay, we know that we know the differentiation of square root. So what we can do is we can say that, let us say f of x is actually 1 plus 3x raised to the power of 4. Okay, then we can say h of x is 1 plus 3x raised to the power of 4. So I am saying that I am now creating another function h of x and f of x as this. So you can naturally see that this is square root of h, right? And then for h of x, I can find out the differentiation of h of x directly. So now I can write this as d of fx by d of hx into d of hx by d of x. Okay, I hope this makes sense. So what does this mean? What does this mean is that I am trying to differentiate d of root h by d of h, right, into dh by dx. All right, so this is what I mean when I write f as 1 plus 3x raised to the power of 4. So in this way now I can differentiate d of root h by d of h. So it is like just like saying d of root x by d of x. So this is 1 by 2. So and you can apply x raised to the power of n type differentiation formula. So 1 by half is because this is root h, and then root h will come into the denominator, and then multiply with dh by dx. So if you take a derivative of dh by dx, we know it is 4x cubed. Right, so this will basically become 2x cube by root h, and root h is nothing but root of 1 plus 3x raised to the power of 4. I hope like you are able to understand what I have done here. That first I have defined the square root, and then I have taken the function inside the square root and called that h, and I have called f as root h. So I first differentiated. To differentiate f with respect to x, I first differentiated with respect to h, which is the function inside the square root, and then I have done dh by dx. So basically this is the approach of chain rule, so that if you have to find a derivative, you can try to simplify it in the form that like root h, for which you already know how to differentiate functions. So let us take another example, just so that you understand what we mean by this. So then I will basically be directly writing this, rather than trying to always write fh, you can also directly write the answer. So let us take the example of another example. We have been asked to find d by dx of tan inverse x whole cube. Okay, so to do something like this, again we know the differentiation of tan inverse x, so we can, but we don't know the differentiation of tan inverse x cube. Just as a formula we don't know that. So what we can say is fx is tan inverse x cube, and we can say that h of x is tan inverse x. So this becomes h cube. So when I write it here as df by dh into dh by dx, I mean that I am differentiating d of h cube by dh into dh by dx, and d of h cube by h is nothing but same as dx cube by dx, which is nothing but dh square, sorry 3h square into dh by dx, and this is 3h square is 3 tan inverse x whole square, and we know the derivative of tan inverse x is 1 plus 1 by x square. Okay, so I hope like this makes sense, that what we are trying to do is to learn to differentiate functions such that we are able to get an answer by knowing the relations which we have already run, tan inverse x, sin x, cos x. So how can we quickly do all this? Like, why we shouldn't always be trying to write fh. So you can do that once or twice or like few more times for your practice, but we should learn how to do this quickly. So let me try to like give you a very easy example of how we can start to learn through this. So let us take this example, square root of 1 plus 3x raised to the power of 4. So now what I will say is that I will think of 1 plus 3x raised to the power of 4 as x, because I know the differentiation of root x. That is how I will think about the function. So what is the differentiation of root x? That is 1 by 2 root x. So you can write it down if you want to think. So let us say you think that we have made the function root x, so I will write as 2 root x, the derivative of that. So what I will do is I will not think of 1 plus 3x raised to the power of 4 as 2 root x as an x. So the derivative of that is 1 by 2 root x. So I will just write 1 plus 3x raised to the power of 4. So by df by dx I am just directly writing now, and now I will differentiate the function which I had initially assumed as x in your mentally. So differentiation of 1 plus 3x raised to the power of 4 is 1 differentiation of 1 is 0, and then into 4x cube. This is exactly what you did here, but rather than trying to always find h, f and all that, you can mentally do it also. So you can then get the same answer without trying to write a lot of steps. This is important to practice again and again. Let us again think of that as in this case, if I do for this case, if you want to do it mentally, you have tan inverse x cube. So we know the differentiation of tan inverse x. So what we will assume is, we will assume tan inverse x as a function as just x. So that is 3x square. The differentiation of x cube is 3x square. So I can then write first 3 tan inverse x square, because I have assumed for some time in my mind this tan inverse x is x. So then 3x square, and now I will differentiate tan inverse x, which I had assumed as x, and that is 1 plus 1 by 1 plus x square. Okay. So rather than writing steps like separately, you can just directly do it. Let us take one more example. So we will not solve it formally, we will just do the problem. So I will just write it here. We have been asked to find the derivative of cos square of tan x. Okay, find the derivative of what is d by dx of cos square of tan x. Okay, so first, this is cos square of tan x. So we'll first assume the entire thing cos square of tan x as x. So we know x square, sorry, cos of tan x. So let us assume cos of tan x as x, right, like we used to do. So then x square differentiation is 2x. So we'll now assume 2 cos of tan x is the first step. Second step is now to assume tan x as x, because now you have to differentiate cos of tan x. So now you can assume in your mind that tan x as the x. So then the cos of x is minus sine of x. So you will multiply this as minus sine of tan x. And now you have to differentiate tan x, because that is what you had assumed as x. So the derivative of tan x as is sec square x. So the answer is 2 cos tan x into minus sine of tan x into sec square x. I hope this makes sense. So let me just write this down here. So mentally, first we assume cos of tan x as x. So x square derivative is 2x. So you said 2 cos tan x. Then derivative of cos of tan x is minus sine of tan x, because you are assuming tan x as x, and then minus sine of tan x. Then tan x derivative is sec square x. And here you don't have to differentiate anymore. So I mean, maybe it is not very clear right now, but if you practice this many times, I'm sure you will be able to understand this very well. You have to practice. I mean, there is no other way to do all these problems. You have to practice again and again and again. And I mean, you should just try to make a lot of problems, look up through textbooks, and then practice them. In the next part of the video, I'll do a lot more complex problems. These were like very simple problems that I was discussing here. So I hope you enjoyed the video and it was useful for you. Please check out the next video in which I'll go through more difficult problems of chain rule.